All right, we are looking at target 5.8, Mastery Learning Objective. And it says, I can use technology to write an equation that models a situation. So we have some vocab. A scatter plot. And a scatter plot is just a way to compare two correlating variables. And correlating just means we believe there's some sort of connection between them. Okay, so for example here, this is chest girth versus length. I don't know what this is, maybe like a dog. Okay, so how wide their chest is versus how long the dog is. So you would think bigger dogs, right, have a wider chest versus smaller dogs or smaller everywhere. So we think these things are correlated. So we'll put a point at the length and the chest girth for each dog. Okay? So then a regression is something we do, and it is a way to model the best equation for the data. So for example, this might be approximately linear, a line, and I would try to draw a line kind of through the middle of my data. And a calculator can do it much better than we can. But we would, right, so we will be using our Desmos, our graphing calculator, for this. But a regression is just trying to find that line that would go through the data. Correlation is how much strong. How strongly the data goes together. So for this, our example is probably pretty strong. They seem to they are clumped along that line, right? If I had another scatter plot, say I was doing height and how well you do on a test. Those things don't seem, right, like they'd go together. Like height versus test score. And it might be just kind of random, right? These things do not have a strong correlation, where these have a strong correlation. So it's how much you would expect, right, the one to influence the other, right? So think of it as like independent and dependent events. Independent events have a strong correlation. Independent events have a weak correlation. Dependent events have a strong correlation. Okay? And then we have this correlation coefficient. It's a numeric representation. I cannot spell today. Numeric representation of the correlation. And it's represented by the letter R. Okay, R is always between -1 and 1. Okay. Positive or -1 is strong. 0 is weak. Okay? A negative correlation doesn't mean it's a weak correlation. A negative correlation just means it's opposite. So like this up here is a positive correlation. As if this gets bigger, this gets bigger. A negative correlation would look like this, right? So as you get older, you have less, I don't know, flexibility. I don't know. Making stuff up. Right. So that would be negative. It still might be a strong correlation. It's just going the other way. Okay? So for example, like this A, right? It's a kind of a middle correlation. It's not super strong, right? So it's not 1, but it's not 0. It's in the middle, but it's negative. Okay. B, I'm going off this picture, has a really strong correlation. So its R value is close to 1. It's 0.9, right? Really close to 1. C, there's like no correlation going on there. They're kind of just scattered everywhere. And so that is no correlation because it's close to 0. So it's a very weak correlation. Okay. So let's look at example 1. Anthropologists use a linear model that relates femur length to height. The model allows an anthropologist to determine the height of an individual when only a partial skeleton that includes the femur is found. We'll find the model by analyzing the data on femur length and height for the 10 males given in the table. Okay. So, again, we are going to use Desmos to do this. Okay. So follow along, and then we'll do some examples in class. We'll do our other examples in class so that we can definitely follow along on our own computer. That is kind of a good idea to start seeing it now. So we'll go to Desmos, and the first thing you're going to do is, not that, I don't know what it is add, and we're going to add a table. I'm going to write that in our notes. So there's this plus sign, and you're going to create a table. Okay? And then you're just going to throw your data into your table. I'm going to, so just to save time, I'm going to pause the video and do that. If during this pause you would like to also do it on Desmos, that would be a great idea. Okay, so I have all of my data. And then something I'm going to do is, usually it has, I'm going to drag it around and zoom out a little bit until I can see my data. Okay, so it's up there. Fabulous. So it looks like a good correlation, but we want to use our Desmos to figure out what that, how strong it actually is. Okay. So zoom so you can see it. Okay. So then we're going to find and graph a linear regression equation that models the data. In order to graph a linear regression equation, all you do is, on here, we're going to type in y sub 1. And when we're in class, we'll really focus on how to get that sub 1 up. If you bring this up, you can get to it that way, but there's a keyboard shortcut, which I find easier. So we'll make sure we all know how to do that in class. Then we do this approximation, so not equals, but approximation, m x sub 1 plus b, right? So we're approximating this line. And it gives us everything we need right here. So again, we type in y sub 1, the squiggle, x sub 1 plus b. And then for what we actually want our answer for to be, right, what equation we're going to write is y equals, and from here, it gives us our m, 1.923, x, plus our b is 80.681. What is the correlation coefficient of the data? And is this a good model? So our correlation coefficient, this r, is right here. Okay, a lot of times we'll use r squared as well. But either of these really. So our r is 0.9658. All right, and is that good? Yes. 0.9658 is close to 1. Then an anthropologist finds a femur of length 58. How tall was the person? Well, I'm going to use the model, but instead of x, right, I'm going to put in this 58. And I'll just use my calculator to figure out what that is. So y equals, I'm just going to use the little one, 1.923. It didn't like that. Hold on. And we get 192.215. 5 centimeters, right? Or really this should still be approximately, but that's okay. Okay, so that's all we're going to do right now. We're going to finish up, we're going to do these 2 examples in class so that we make sure we all have it down on how to put everything in Desmos. So make sure you do have your laptop tomorrow so that we can do these in class. Otherwise, that is it, and have a great rest of your nights.